Guys, on the line of part of my series where I do reinforced concrete and talking about steel. This is steel rebar, not post-tensioning steel. Um, okay, so this is a passive system, and it becomes active once it's loaded and once it's cracked, once the concrete cracks, and once it's loaded. I would guess theoretically it will become active just at the point of the crack. As soon as it's cracking, it becomes active. It's without a delay. Um, all right, so let's talk about adding number 5 rebar instead of everyone using half-inch rebar. What happens if you step it up to 5/8 rebar and you change your spacing from 12 inches to 9 inches? Well, scroll down here. Let me give you tell you where the source is. This is Iowa Department of Transportation. It's one of their booklets called, give me a second here. It's called, if you want to Google it, Reinforcing Steel Placement Handbook. It's 20 pages long per my pages. All right. So what happens at 9-inch spacing as opposed to 12? You use a number 5 rebar, and you can now get almost 4,000 psi concrete, respectively, if you do a 2-inch clearance still with 12-inch spacing with the 5 rebar, number 5 rebar. You've now down below 3,000. So you've got roughly right about here about 3,800, and at 12-inch spacing, you're down about 2,800. So 1,000 psi loading ability that you lost. Now, do you do that? Well, it's 20. Let's just look at the number 4 rebar again. I'm sorry. So that was like 2,700. 9-inch. Oh, I was at 12, right? 9-inch spacing. Number 4 brings it down to 27. I was up here for a second here. All right, 12-inch spacing. Yeah. So that was fair. Right. So now, does this matter? 9 inches over 12 inches. Well, do your cost analysis, and also think about your load. If you're not going to have a load on there greater than, well, let's think about this. If your load is greater than 2,800 or right about 2,800, and this is your spacing, and you can figure out that your loads are greater than 2,800 psi, then you should not be doing this spacing, and you have to do your load calculations on your whatever your columns are, etc. So if you got a column in there and you figure out your load on that column is going to be greater than 2,800 psi, well, then your spacing is off here. You need to step your spacing up so you can have a stronger steel reinforcement there. At say this would give you, if you're 9-inch spacing, would get you up there another 1,000 psi. Would that give you a margin? You want to throw some margin in there too. Don't forget you might have snow loads, wind loads. Now let's take away wind loads. A water load, backed up drain, and then excess water on the roof, unless you've got a pitch roof and it just overflows the gutter. Things like that. Just think about the two there. It would be snow and water, I would think, and ice. And also, if you're going to have an air conditioner put up there by one of the columns, if you load it on the roof, so you can see where you're for you guys doing your own engineering, if you will. You can see where 9-inch spacing will give you more safety. Now, if you're doing your driveways now, even this 9-inch would give you that. So think about the cars that are coming on there, and don't forget, when they slam on brakes, a truck, if you do the loads on it, it will increase the front braking. When you brake, that front loads will increase significantly. If you're not sure of what it is, try to find the curb weight of it online. Also, if you can figure out if it went to motor vehicle, if you can find motor vehicles brake testing, they put a shock load on an instant brake. That gives you your maximum where you're going to be loading that front of the vehicle. With one person in the car, typically it's one person in the car, but I don't think a couple of people are going to change you off too much. But they do a nice test at motor vehicle where they make you come forward and slam on brakes. That's a nice surge. That would be equivalent to a garage, coming into the garage and overdoing it. So that's where you want to make sure that you're at this PSI. It's related to the tire pressure, the surface area, and all that. But that's for you guys doing your own engineering. your spacing of your bars here, number 5. And there we go. I hope this was somewhat helpful for you. I just wanted to give you a quick teaser, give you some quick breakdown of that. Let's do this before I run away. Let's go to their drawings, diagrams. Neutral axis, location. You want that 2-inch cover. And if you take note here, here's 2-inch cover with the 5. This is what happens when you put a 3-inch cover on it. You now get a reduction. So it really does matter, this cover. The cover really does matter. You'll see a 6-inch pad typically will put the 2-inch chairs on it. So some of you guys will do 4-inch concrete and put a 2-inch chairs on it. Well, you're changing your axis, your loading, your neutral axis. So keep in mind where your spacing is for your loads. 2-inch, 3-inch. See the big difference? It's a big difference on it. So and those people that just pull up the rebars, we watch videos where people just use a hook to pull the rebar and the wire up. You can see that they're significantly making their concrete just junk. It's just a random up and down pattern of strength from, reduction from, let's see. So we're at 38, and what's this guy there? Down to about 28. 38, 28. Nope, 32. So it's a significant ratio, up and down cycle when just pulling it up. So you never want to just pull your reinforcement up. You don't want to walk on it where it deforms because you're making this crazy cycle of your reinforcement, of your strength of your concrete. And remember that it works once you have a crack in the concrete. The steel becomes active during loading. Once the load's off, it's a dead load that is active under. But your live load is what then really puts the concrete steel at its working position. You need that grip. So make sure you guys don't put oil on the damn I think they talk about that perhaps. Don't make sure there's no oil on your bars when they're spraying it. Leave that oil off the bars. Make sure there's rust. It's limited rust. Really get that rust off of there. You don't want rusty rebar. Really protect your rebar. You don't want it already having the rust on it, which is a debonding agent, right? You think about it. Rust is a debonding agent. It's equivalent to putting down sand, then putting your concrete on top of the sand. You can imagine I could slide the pad right off of it then, right off whatever's below the sand. So that's what rust does. And I guess I should have did a different video on that. But take care, guys. Enjoy.